Hello and welcome. So on today's video, I wanted to cover one of the initial topics in the new specialization exam for CCNP Security. There's the implementing secure solutions with VPN. So along those lines, with that particular book that just released within the past month or so, I want to go over GRE and then also GRE over VPN, which is one of the topics that's covered. And so I've got topology going on here in CML. Basically, I'm not going to go over the theory of GRE too much, but a lot of good articles and videos out there, and wanted to put together a solid example, specifically using CML. So basically, the GRE encapsulation is going to happen between router 1 and router 3, and then router 2 is kind of simulating an ISP or an internet connection. And so essentially the R1 and R3 are peers in a GRE tunnel. And then we have the Linux host that we'll use to kind of test and generate traffic from. So go ahead and get started here. I have the notes on the right hand side here, and then this is all zoomed in, so hopefully this is going to come across well in the video. Okay, so we're starting on router 1. We'll go host name R1. And the first interface we'll configure is the one on the right here, which is going to be the link with the internet on R2. So that's going to be gigabit Ethernet 00. So interface gig 00. IP address 192.168.10.1, and a better way of simulating this would be to actually use public IP space, but it won't make too big of a difference in the example. And so now we'll configure the interface for the LAN segment, which is going to be gig 01 here for the Linux host. Okay, so the LAN segment's going to be /29 172.16.10.0. So for R1, we've got the internet-facing interface and also the LAN interface configured here. I've got loopbacks in the notes here, but I'm not actually going to implement this here because it's not necessary. A lot of different ways to do this kind of example. So now I'm going to start working on the DHCP configuration for this Linux host on R1's LAN segment. So we got no IP DHCP conflict logging, IP DHCP excluded address. In this case, we're just going to be extra careful not to allow what's going to be the default gateway for the Linux host is going to be 172.16.10.1. We just don't want to have that leased out for DHCP. And then I'm going to create a DHCP pool. We'll call it LAN _0/1. And then the network. default router is going to be the 10.1. And then we're going to only advertise the gig00 interface for OSPF. So the routing between R1, R2, and R3 are all going to be done through OSPF area 0, but we'll see that the routing for the LAN segments, both for R1 and R3, is going to be handled a little bit differently, so that the routing for those LAN segments is forced through a tunnel interface that we're going to configure. So we'll start up the OSPF process here, advertise this interface. Okay, so that's going to be good for router 1 for now. Move over to router 2. Change the host name, and then again we're just going to configure interfaces here. So basically the gig00 is going to be the link to R1, and the gig01 will be the link to R3. So that's going to be a /30 network. And again, R2 is basically the ISP, and then that's the link to R1. So we got gig01 is going to be the link to R3's internet facing interface. And then I got to do OSPF. So we're just advertising each side of the R2 router here and its interfaces. And again, it probably would have been better to choose some public IP space to make the example a little bit more realistic, but not too big of a deal. Okay, so we'll move on to R3. Okay. So we got interface gig00, which is going to be the interface for the ISP. We got gig01 for the LAN interface. In this case, it's going to be 10.0.10.1. 20.1/29 mask. And then again, we'll be advertising the interface for the internet. Okay, and then we're going to set up DHCP for the LAN segment here. And then again, just being extra careful to exclude what's going to be the default gateway from that DHCP pool. Okay, so now that we have this, we've got DHCP that should be running on both the R1 and R3. I'm going to go ahead and start the Linux hosts, and then hopefully they come online and grab a DHCP address. So now that we have kind of a working topology, we should have good connectivity across these 3 routers. So probably should check that. And so R3, for instance, an IP address I would want to ping would be its gig00. So we'll do a ping to 192.168.20.2, which we can get to that. So we know we can get across these routers, and OSPF is running for us here. So now want to get into the main point of the video, which is configuring a GRE tunnel. So what we're going to do here is create the tunnel interface. So we're going to call that tunnel 0, and I'm going to give it an IP address. This is going to be 192.168.0.0 on a /30 network, and you'll see that the tunnel and then both tunnel interfaces for R1 and R3 are going to be inside that network. And then we're going to specify the tunnel source as gigabit 0/0, which is the internet facing interface. And so again, the R1's gig00 is going to effectively pair up with the gig00 interface of R3. And then the GRE encapsulation is going to go across the internet, if you will, here. So there could be many routers and different network hops represented by R2 here. But we're creating a tunnel, a GRE tunnel, through these tunnel interfaces. The encapsulation will make it appear that these are R1 and R3 are layer 2 adjacent. So we've set our tunnel source, and then so again the tunnel destination is going to be R3's gig00, which is the kind of like the peer IP, if you will. So that's going to be tunnel destination 20.2, And then tunnel mode is GRE IP in this case. Okay, and then as far as routing goes for the, because we want to be able to get to the whole point here is right now there's no routing between the LAN segment for R1 on the far left and the LAN segment on the far right for R3. Currently there's no routing. The only routing that's happening here is kind of the simulated internet connection between R1, R2, and R3. So basically what we're going to say here is that this LAN segment on the far left of R1 wants to be able to communicate over GRE encapsulation to the LAN segment on the far right, which is this 10.0.10.0/29 network. So we're going to specifically put a static route to say if the destination is going to be this 10.0, it needs to go through the tunnel 0 interface that we just created. Okay, I was missing. Okay, so we got the static route in there, and then we can do show interface. Actually, we'll do IP interface. We can call it ton 0. So we can see interfaces up. Got it on the /30 network here. Okay, so you can see that our gigabit interfaces are up, and then this tunnel interface that we just created is up as well. So we'll go to R3 and do the kind of mirror configuration. Okay, so we got its IP address, same /30 subnet as the tunnel interface on R1. And then same thing, tunnel source is going to be its gig 00 interface, which is the internet facing or ISP facing interface. So tunnel source going to be gig 0/0. Tunnel destination, that's going to be the essentially the peer of this GRE tunnel, which is going to be R1's gig 00, which is 192.168.10.1. Tunnel mode GRE IP and no shut. So the tunnel interface came up, and then we'll put in our static route that basically says from this LAN segment on the far right, we want to be able to get to the 172.16.10.0 network /29, which is over on the far left, the LAN segment for R1. And then that traffic will pass GRE encapsulated between the two GRE peers, R3 and R1. Decrease the zoom, -1 here. So basically, if we look at the routing table, basically what's going to happen is if we want to go to the 172.16.0.0/29, because we're in the context of the far right Linux host here, and we want to get all the way across the internet over to this LAN segment on the far left. Any traffic that's destined for that network is going to be forced through this GRE tunnel interface. So now we can check in on the Linux host here, and then hopefully this will be booted up with its DHCP address, which it is. So we got, turned out to be the .2, and we'll find that the 10.1 is the default gateway. So this one's booted up. It's got its DHCP address. So I'll check the one on the far left here. And take a look. That one's also good. So what I should be able to do then is I should be able to ping 172.16.10.2, which I get a ping, and then let's look at a trace route, because we kind of want to prove that this is happening over GRE. And so if we look at the trace route, we'll see that that's actually correct, because so we're on the far right side here. The first hop is the default gateway of the Linux host, which is R3's 0/1 interface. And then when it hits that and gets considered for forwarding, as we looked before, we know that there's a static route for this network, and it's being forced to the tunnel interface. And that GRE tunnel is paired up with the next hop in the trace route, which is the 192.168.0.1. So if we go all the way back to the notes here, you'll see that R1's gig 00, which is the internet facing one here. Indeed, it's 192.168.10.1. And then of course the next hop in the trace route is the actual Linux host on the far left, with the IP that we trace to. So we know for sure, based on this trace route, and that this is happening over GRE encapsulation. And then another thing that we can take a look at is we'll do a show interface ton0, and so we looked at this a little bit earlier. Tunnel source, tunnel destination. So these are kind of like the GRE pairs they were talking about before. And then there's some counters of packets that are going across. So we know that these ping traffic and the trace route traffic is showing up. So between looking at the status of this tunnel interface, the GRE tunnel interface, and the output of the trace route, then it's clear that we definitely have connectivity between these two Linux hosts over a GRE tunnel. So that's it for this video. Taking this example, on the next video, we'll do the same GRE tunnel, but over IPsec. So thanks for watching, and hopefully that was helpful.